Yes, ma. Let us see definition of concyclic points, ma. Let us take 4 points, ma. Some A, B, C, D. Let us take 4 points A, B, C, D. Those 4 points are said to be concyclic points. Those 4 points are said to be concyclic points if those 4 points can lies on the same circle. If 4 points A, B, C, D can lies on the same circle, then those 4 points are called as concyclic points, right? This is the definition of concyclic points. Now, how can you proceed in the problematic area that concyclic points? That means, when do you say 4 points A, B, C, D are concyclic points in the problematic area? For that, let us see some steps now. Suppose these A, B, C are given points now. To check whether these are concyclic points or not, first of all, let us prepare a circle according to these 4 points now. But already you know, circle means what ma? In our 3-dimensional geometry, the combination of sphere equation with plane equation ma. That means, by using this given data ma, let us prepare a sphere. Again, by using that same data, let us prepare a circle. Let us prepare a plane. Once again I am repeating ma. By using given data, prepare a sphere and prepare a plane. The combination of those two things gives a circle, ma, right? Now, by using these 4 points, how to proceed that situation, ma? For that, problematic area should be like this, ma. In step number 1, ma, let us proceed this sphere OABC. O means origin, ma. Let us prepare sphere OABC. There O is origin. A, B, C are given points for you, ma, right? Keep this result aside, ma. And then in the step number 2, let us prepare a plane passing through the points A, B, C. Prepare a plane passing through the points A, B, C. This is your plane equation. Combination of this sphere and plane gives a circle. Here, to proceed, your given 4 points are concyclic or not, we are not using this D point. Now, if suppose this D point can lies on this sphere and this plane, you say these 4 points are concyclic points. This D point should lies on this sphere and this plane. Means whenever you can substitute this D point in these two equations, both must satisfy. In such case, we say that those 4 points are concyclic points. Once again I am repeating. First prepare a sphere passing through the points O, A, B, C. O means origin. That is not in the statement, but you have to take that origin, general condition, right? After that, let us proceed a plane passing through the points A, B, C. If this D point can lies on this sphere and this plane, you say that D point must lies on this circle. Now we say these 4 points must lies on a same circle. Hence, those are what? Concyclic points. This is your problematic area in concyclic points. Now, let us see one problem in this section. Means they will give 4 points, A, B, C, D. Verify or prove that those are concyclic points. Yes, problem here it is. Prove that the points (5, 0, 2, minus 6, 0, 7, minus 3, 8, and 4, minus 9, 6 are concyclic points. This is your question for you. Prove that the points 5, 0, 2, 2 minus 6, 0, 7 minus 3, 8, 4 minus 9, 6 are concyclic points. Already I explained how to solve it. Let us take those points as first one is A, second one is B, C, D. That one I am writing. Given points are A 5 0 2, B 2 minus 6 0, C 7 minus 3 8, and D 4 minus 9 6. These are given points for you, right? What is your first step, ma? First of all, you have to prepare a sphere which can passes through the points origin O, A, B, C, ma. For that, first of all, I want to proceed general form of the sphere, ma, right? Here clearly I am writing, ma. Now prepare a sphere passing through O, A, B, C. This is first step, ma, right? For that, take general form of the sphere, ma. You know general form of the sphere, ma. The general form of sphere is what is that, ma? X square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. This is general form of the sphere, ma, right? Now let us take this will passes through this origin, ma, right? Let O 0 0 0 is a point on above sphere. But whenever it is a point on above sphere, substitute x equal to 0, y equal to 0, z equal to 0 in this relation, ma, you must get d equal to 0. Now directly we got d value here, ma, substitute the d here, right? Then it will reduces to three unknowns quantity, u, v, w and w, ma, right? Now use that condition. I mean substituting d equal to 0 in 1, we get x square plus y square plus z square plus 2ux plus 2vy plus 2wz is equal to 0. This is our main sphere equation. Here u, v and w are unknown quantities. Find them. To find those values, you know, this A is a point on here, this B is a point on here, this C is a point on here. Substitute them, you get three equations in terms of u, v and w, ma. Solve them, you get u, v and w values. And then substituting those values here, you get your sphere, ma, right? That work now I am going to do, ma. Now take this condition, ma. Let capital A, what is that, ma? 5 0 2 is a point on above sphere. This implies, yes, substitute the values, ma. 5 means 25, already it is 0y, this is plus 4, right? Next plus x is 5, na, 10u. Now already y is 0, right? Let us go for so z is 2, ma. It is plus 4w is equal to 0. Otherwise simplify this relation, ma. This implies your relation is 10u plus 4w is equal to minus 29. Let it be, this is some relation number 3 or whatever it may be. You can continue with your own notations, ma, right? Yes, this point is our, next go for this point, ma. Let capital B, what is that capital B, ma? 2 minus 6 0 is a point on sphere equation 2. That's why I am writing simply sphere 2, ma, right? This implies, yes, substitute x is 2, ma. X is 2 means 4 2 square, y is minus 6 means plus 36, right? Z is 0, no need to substitute. X is 2 plus 4u plus 4u, y is minus 6 minus, y is minus 6 minus 12v W is 0, is equal to 0, right? Now solve again this relation ma. If you can solve this, you get one expression like this ma. 4u minus 12v is equal to minus 40. Let it be, this is number 4, equation number 4 ma, right? Like this, go for last point, C point ma. Let capital C, what is that C point ma? 7 minus 3, 8 is a point on sphere equation 2 ma, on sphere 2. This implies, yes, 7 means 7 square 49 plus 9 3 square plus z square 64 plus 14u minus 6v plus 16w, 8 to the 16w is equal to 0. Okay na? 7 square is 49, 3 square is 9, 8 square is 64, x is 7, 7 into 2, 14u minus 3 into this 6, 3 into 2, 6v, next 8, 8 into 2, 16w is equal to 0. Again simplify this relation ma, you get expression like this. It is 14u minus 6v plus 16w is equal to, yes, once see how much this ma, 60, 40, 104, 113, 113 plus 9, 122, it is minus 122. This take it as number 5 ma, right? Like that we got expressions ma, right? Now in the next step ma, let us solve equations 3, 4 and 5 ma. Solving equations 3, 4 and 5, we get, yes, I am writing directly the values of u, v, w ma. You solve ma. In our material I given complete simplification, I did complete simplification in that ma. Once see there, easily you can understood ma. But here I am going to write directly u, v, w and w values ma. U value is minus 1 by 2 ma. V value is 19 by 6 ma. 19 by 6 and w is minus 6 ma. U is minus 1 by 2, u is minus 1 by 2, v is 19 by 6 and w is minus 6 ma. After getting u, v, w ma, substitute them in equation number 2. Substituting the values of u, v and w in equation 2, we get, I am writing directly expression ma, simplified expression, but substitute them and simplify it ma, you get expression like this ma. X square plus y square plus z square, x square plus y square plus z square minus x plus 19 by 3 into y minus 12z is equal to 0. This is your sphere equation ma. Let it be big expression number 1 for our convenience ma. Now sphere equation you got ma. Once verify this sphere is passing through this D point or not, here only verify it is better ma, right? For that substitute the D point here ma. Let us substitute, let us substitute point D in big expression 1. We have what we get ma? 133 minus 72 minus 71, which equal to 0. That is sphere, big equation 1 passes through point D. Let us keep this one in mind, ma. One condition is over. What is that, ma? We define a sphere passes through OABC points and that sphere is passes through this D point, ma, right? Next, let us define a plane passes through ABC points, ma, right? Yes, define a plane passes through A comma B comma C. Yes, you know what is the plane can passes through 3 points, ma. If x1, y1, z1 are 3 points, ma. The equation of the plane passes through those 3 points, what, ma? x1, y1, z1, x2, y2, z2 and x3, y3, z3 are 3 points, ma. There that equation is matrix determinant x minus x1. X minus x1. X1 means what, ma? This x minus 5, y minus y1, y minus 0, z minus z1, z minus 2. That is x minus x1, y minus y1, z minus z1. Next go for next row, ma. x2 minus x1, y2 minus y1, z2 minus z1. Next x3 minus x1, y3 minus y1, z3 minus z1. Matrix determinant equal to 0. That is a plane which passes through 3 points, x1, y1, z1, x2, y2, z2 and x3, y3, z3, ma. Right, first row we got, ma. Next go for second row. x1 minus x2. x1 is what, ma? Sorry, x2 minus x1. Any order you can prefer, better x2 minus x1. x2 minus x1 is what, ma? 2 minus 5. Next minus 6 minus 0. Next 0 minus 2. x2 minus x1, y2 minus y1, z2 minus z1. Next x3 minus x1, 7 minus 5, y3 minus y1, minus 3 minus 0, z3 minus z1, 8 minus 2. This matrix determinant equal to 0, right? Now let us simplify this expression, ma. Simplify it, ma. It is matrix determinant x minus 5, y, z minus 2, next minus 3, minus 6, minus 2, next 2, minus 3, 6. Matrix determinant equal to 0. Now let us solve that 3 by 3 matrix, ma. Let us simplify that 3 by 3 matrix, ma. You must get this relation, ma. X minus 5 into this corresponding row and column delete, ma. Minus 36, minus 36, minus 6. This corresponding row and column delete, ma. This into this minus this into this, right? Next minus y, sorry, y into its corresponding row and column delete, ma. Minus 18, this into this, minus into minus plus, ma, plus 4. Next minus, plus z minus 2 into its corresponding row and column delete, ma. It is 9 plus 12. 9 plus 12 is equal to 0. Now simplify this total expression, ma. Directly I am writing that simplified form, ma. It is 42x complete after taking minus 1 common I am writing, ma, plus 14y minus 21z minus 168 is equal to 0. After simplifying this, you get this expression, ma, right? Now let it be, this is big expression number 2, ma. Now let us verify this is passes through D point or not. For that one, substitute your D point, ma. 42 into, directly I am writing 42 into 4 plus 14 into minus 9 minus 21 into 6 minus 168. How much it is once look, ma? 42 into 14 into minus 9 minus 21 into 6, ma. It is totally 0. Once simplify this result, ma, right? Here you can write, ma. Therefore plane equation number 2 passes through point D. Yes, this also keep in box ma. Okay, now once see these two box areas. D point lies on this sphere and this plane ma. Combination of this plane and this sphere gives what ma? Circle. Means D is a point on the circle. I mean we form a circle ma, which can passes through these 4 points. Otherwise we say these 4 points must lies on same circle. Hence we say given 4 points A, B, C, D are what ma? Concyclic points ma. This is about your concyclic points relation part ma. Any problem if they given, they will give 4 points ma. Let us proceed. Those 4 points are concyclic or not ma. In such case, first let us prepare a sphere which can passes through origin A, B, C points ma. After that, define a plane which can passes through the points A, B and C ma. If D point can lies on given getting sphere and getting plane ma, you say given 4 points are concyclic points ma. This is about concyclic points concept. Yes, now see definition of a tangent plane to the sphere ma. Tangent plane to the sphere. Tangent plane to the sphere. Yes, once see its definition ma. When do you say a plane is tangent plane to the sphere ma, right? If suppose a plane and sphere are intersecting to each other ma, and if there exists only one common point between them ma. Let us take one sphere and plane ma. Both are intersecting to each other. If there exists exactly one common point between them, then the plane is called as tangent plane to the sphere. Otherwise you say that if a plane can touches the sphere at single point ma, then that plane is called as what ma? Tangent plane to the sphere ma, right? Clearly I am going to proceed graphically ma. This is your sphere ma. For my convenience I am taking s equal to 0. Generally sphere notation s equal to 0 we have to take ma. This is the plane ma, which is intersecting with the sphere ma. This is the common point between them. I want to take that point is something like P ma. I am proceeding this plane is notation L equal to 0 ma. This plane and sphere are intersecting to each other and only one common point is there ma. Now we say this plane is what ma? Tangent plane to this sphere ma. This plane is tangent plane to that sphere ma, right? Now according to this diagram ma, we can proceed one mathematical expression here ma, for a tangent plane condition ma. If suppose a plane is tangent plane to the sphere or a plane can touches the sphere ma, then the perpendicular distance from center of the sphere to the plane is same as radius of the sphere ma. Once again I am repeating ma. If a plane is tangent plane to the sphere or if a plane can touches the sphere, generally touches means plane should be tangent plane to the sphere ma. In such case the perpendicular distance from center of the sphere to the plane is same as radius of the sphere. Center of the distance center nundi plane ki distance calculate cheyandi, sphere center nundi plane ki, that should be equal to the radius of the sphere. In such case only we say that the plane is touches the sphere or that plane is tangent plane to the sphere. Once again I am repeating that condition. If a plane can touches the sphere, then the perpendicular distance from center of the sphere to the plane is same as radius of the sphere ma. This is about your sphere tangent plane to the sphere definition ma. Now let us see theorem ma, important theorem. I think in our approach it is theorem number 6 ma. Theorem number 6. Yes, its statement is prove that the equation of tangent plane to the sphere s equal to 0 at the point x1 y1 z1 is s1 equal to 0. In the notation spot I given what is s notation and what is s1 notation ma. S means our regular sphere ma, x square plus y square plus z square plus 2ux plus 2y plus 2wz plus d ma. S1 means what ma, x1 plus y1 plus z1 plus u into x plus x1 plus v into y plus y1 plus w into z plus z1 plus d equal to 0, right? Otherwise the same statement you can write in the expanded form also, that s notation, instead of s notation you can proceed the s part ma, s and s1. Prove that the equation of tangent plane to the sphere x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0 at the point x1 y1 z1 is yes is what no, x1 plus y1 plus z1 s1 condition ma, plus u into x plus x1 plus v into y plus y1 plus w into z plus z1 plus d equal to 0, right? But as formula wise try to remember first condition, it is better. The equation of the sphere s equal to 0 at the point x1 y1 z1 is what ma, s1 equal to 0. That theoretically we have to show ma. Yes, to prove that result first I want to plot diagram ma, right? Let us take sphere. This is our sphere ma, s equal to 0, right? This is your tangent plane. We have to form this tangent plane equation only, right? This is this plane equation you have to form. In the question they given point of contact ma, this is point of contact, that one I am denoting with p. What is that ma, x1 y1 z1, that is point of contact ma, right? In the next step ma, here in the calculation part I want to define center of the sphere first ma, right? Your sphere equation is s equal to 0 na, center is what ma, minus u minus v minus w, this is center ma. And then define radius also, square root of u square plus v square plus w square minus d ma, right? First I am going to write those theoretical steps here ma. Given sphere is yes, which is what ma, x square plus y square, directly I am writing in both situations ma, this and this combination, s equal to x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0 with center see, what is that ma, minus u minus v minus w, and radius r is equal to, actually this is not required, just I am writing u square plus v square plus w square minus d, right? Here especially see the diagram. I want to take this p point also here. Let p x1 y1 z1 be the point of contact. Point of contact means what ma, common point between your required plane and given sphere ma, right? This p is point of contact ma. In the next step I am going to define this CP line direction ratios ma. Direction ratios of line CP are yes, x2 minus x1 y2 minus y1 z2 minus z1, any order you can write. It is x1 plus u y1 plus v z1 plus w. Clearly I am writing ma, x2 minus x1 y2 minus y1 z2 minus z1, right? Now once look ma, is it this CP line is perpendicular to this plane or not? CP line is perpendicular to this plane means is it this CP line is normal to this plane or not? Now this CP line direction ratios are what ma? Normal to the plane direction ratios means this is A, this is B, this is C, or normal to the direction ratios of the plane ma, right? That means these are direction ratios of a line which is normal to our required plane ma. That work I am writing here ma, right? We know that line CP is normal to required plane. Okay, once come on to this diagram. Now on this plane you know a point P is a point on this plane and you know direction ratios of the normal to the plane. So that is it possible to define plane equation or not? In the definitions, planes definitions I proceed. If you know a point x1, y1, z1 on the plane and a comma b comma c are direction ratios of the normal to the plane, what is the plane equation ma? A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Here these are a, b, c values ma, and this is x1, y1, z1 as usual ma. That work I am going to define in the next step ma. The equation of a plane passing through the point P x1, y1, z1 and having DRS of the normal to the plane that is in term normal to the plane in brackets I am writing ma. It is x1 plus u comma y1 plus v comma z1 plus w. That means basically these are a, b, c ma. Now this is x1, y1, z1. Then what is the plane equation ma? A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. That work I am doing here. This implies is, that means the equation of the plane passing through this point and having normal to direction ratios, this is what ma? A means x1 plus u into x minus x1 plus y1 plus v into y minus y1 plus z1 plus w into z minus z1 equal to 0. Clearly I am proceeding here formula ma. A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. That formula we used here ma. Yes, in the next step ma, let us go simplification of this ma. I am going to simplify this result ma, right? That is first one once look ma. x1 I am writing in the order like this ma. x1 x into x1, otherwise complete do ma better. x1 minus x1 square, one more step I want to increase ma, plus u into x minus x1. I want to keep this as it is. This into this minus this into this plus this into this I am writing as usual ma. Plus next relation ma. Clearly I am keeping in box each and every term for your convenience. Next one is what ma? y1 minus y1 square plus v into y minus y1 plus next one z1 minus z1 square plus w into z minus z1 equal to 0. All the terms we got. Still I am going to write this expression for my convenience like this now. Xx1, this is first term, plus yy1 plus zz1 is one combination, xx1 plus yy1 plus zz1 more, plus u into x minus x1 plus v into y minus y1 plus w into z minus z1 minus, in remaining things these three terms take minus common, minus of x1 square plus y1 square plus z1 square is equal to 0. Let it be, this is some equation number 1, keep aside, right? Again let us go to your diagram. If you can observe this diagram, this P point is on the sphere also, not only on the plane, it is also on the sphere. That means this P is a point on this sphere. Whenever P is a point on this sphere, is it satisfies your sphere equation or not? That work I am proceeding. That means here in this sphere equation, replace x with x1, y with y1, z with z1. That work we are doing in the next step, right? We know that P x1, y1, z1 is a point on the sphere. What is that sphere, ma? S is equal to x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. I am not using S notation in the next simplification part. Whenever this is a point on this, you can replace x with x1, y with y1 and z with z1, so that you get this expression, x1 square plus y1 square plus z1 square plus 2ux1 plus 2vy1 plus 2wz1 plus d is equal to 0, right? In the next step, keep this as it is, this take on to other side. I mean this I am going to write x1 square plus y1 square plus z1 square. Keep left side, remaining all terms take on to other side. That's why I am writing minus of 2ux1 plus 2vy1 plus 2wz1 plus d. Let it be, this is number 2. Now substitute 2 in 1, especially this part replace with this part, right? Substituting 2 in 1 using equation 2 in equation 1, we get, yes, it is what, xx1 plus yy1 plus zz1 plus u into x minus x1 plus v into y minus y1 plus w into z minus z1. This part up to here it is over. Now here so we are substituting this, now minus into minus becomes plus, now plus this total result 2ux1 plus 2vy1 plus 2wz1 plus d is equal to 0. Again I am simplifying this result, xx1 plus yy1 plus zz1, up to here I am not changing, here this in between these two things take u common. If you can take u common, x minus x1 plus 2x1 minus x1 plus 2x1 becomes what? Plus x1 or not? Otherwise this total thing how can you write, plus u into x plus x1, here also plus v into y plus y1, here again in between these two things take w common, plus w into z plus z1 plus last d is equal to 0. Just on simplifying this above result you get this. Is it, this is s1 equal to 0 or not? Once go to notations, this is s1 notation. This be equation of tangent plane to the sphere s equal to 0 at the point x1, y1, z1. This is about your theorem, right? Here we did this theorem. Now this same theorem again we have to do in other 2 units also. There instead of sphere here we can take cone in the second unit, conicoid in the third unit, but notation should be same. But S maybe changes. Here S is sphere ma, this is the sphere, general sphere ma. In cones you can take here S is cone ma, cone equation is different. In conicoid yes you can take conicoid, but basic concept is same. Basically this is the formula also. This formula is you can use in all situations in remaining 2 units also. Simply remember formula like this ma. The equation of a plane, the equation of a tangent plane to the sphere S equal to 0 is S1 equal to 0. The equation of tangent plane to the sphere S equal to 0 at the point x1, y1, z1 is S1 equal to 0. In the problematic part, this formula all of you must remember. This is about your theorem. Yes, now see next theorem. Theorem number 7. Prove that the condition for the plane Lx plus My plus Nz equal to P should touch the sphere x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0 is Lu plus Mv plus Nw plus P whole square equal to L square plus M square plus N square into U square plus V square plus W square minus d. That means if this is equal to this ma, you say this plane touches this sphere or this plane should be what ma? Tangent plane to this sphere ma. That condition theoretically we have to show ma. For that first of all I want to plot diagram for above data ma. This is our given sphere ma. This is our sphere. For my convenience I am taking it is S equal to 0, right? And this is your plane ma. What is that plane? Lx plus My plus Nz equal to P or minus P equal to 0. Anyway you can write. Now for this sphere ma, let us define center. For this sphere, what is the center ma? Minus U, minus V, minus W. It is center ma. And you can define radius. Radius also you can define ma. Square root of U square plus V square plus W square minus D. This is the point of contact. For my convenience I am taking this point as capital E. I am not using P point because initially P we got in the plane ma as a term. That's why I am using new notation A ma, right? Now once look this diagram. If this is point of contact ma, is it CA line is radius of the sphere or not? That means whenever this plane can touches this sphere ma, the perpendicular distance from center of the sphere to the plane is same as radius of the sphere ma. Use that condition, directly you get this relation ma. I am proceeding that work only here, right? First take your given sphere ma. Given sphere is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0 with center capital C. I am taking minus u minus v minus w and radius r is equal to square root of u square plus v square plus w square minus d, right? Now in the next step ma, let us find perpendicular distance from center of the sphere to this plane. Perpendicular distance from this point to this plane calculate ma. The perpendicular distance, directly I am using the notation, the perpendicular distance from point C to the plane Lx plus My plus Nz equal to P or minus P equal to 0, any order you can write. Minus P equal to 0 is in formula list I given ma, from a point to plane perpendicular distance ma, it is L into minus U plus M into minus V plus N into minus W minus P whole by square root of L square plus M square plus N square. This is the perpendicular distance from center of the sphere to the plane, right? Now let us see, is it this is same as radius or not? From the above diagram, clearly I am writing. From the above diagram, we can observe that the perpendicular distance from center of the sphere to plane is same as radius of the sphere. Right? Yes. Here we got perpendicular distance and here got radius of the sphere, equate them. This implies modulus. Here you can take totally minus common. Inside the modulus you can proceed minus as plus. It is Lu plus Mv plus Nw plus P whole by square root of L square plus M square plus N square is equal to square root of U square plus V square plus W square minus D. Right? Now do cross multiplication, after that you can square it. First I am doing cross multiplication. This implies mod Lu plus Mv plus Nw plus P is equal to square root of L square plus M square plus N square into root of U square plus V square plus W square minus D. Now squaring on both sides. Squaring on both sides, we get, yes, it is Lu plus Mv plus Nw plus P whole square is equal to L square plus M square plus N square into U square plus V square plus W square minus D. This is the condition. This condition, in what position we got? At what position we got? Whenever this plane is tangent plane to this sphere, we got this condition. That one only your statement, right? What is that statement? The condition that the plane should touch the sphere is what? Lu plus Mv plus Nw plus P whole square is equal to L square plus M square plus N square into U square plus V square plus W square minus D. This is about your tangent plane to the sphere concept, right?